So I'd now like to hand over to Preetesh from Pro-Lite, who is going to start giving us the webinar.
Brilliant.
Preetesh.
Thanks for the introduction, Dave. So as Dave mentioned, I am from Pro-Lite Technology. We are a company that's been working in the photonics domain for well over 20 years now. We are here today to discuss the laser safety of handheld applications. It's a topic that's come up quite often recently due to the availability of handheld lasers for applications such as cleaning and welding. So just to give you a quick flavour of what we're going to cover throughout the webinar, be a short introduction on Pro-Lite, a little bit of info on what we need to do before we start working with these kinds of lasers, followed by an overview of the hazards that we may encounter and the standards that we need to adhere to. And then we'll move on to personal protection equipment, hazards and other protection things that we can employ to make sure we are all working nice and safely. So the Pro-Lite Group, just to give you a little flavour, we were founded in the UK back in 2002. We are now a group of 4 companies. There's Pro-Lite France, Spain, and Sphere Optics in Germany. We have roughly 35 staff across all groups, 15 graduates and 2 PhDs, although that might have increased since this number went up. So I'm from the photonics division, so I deal mostly with lasers. My personal experience within the photonics industry has been almost 15 years working in sales and applications with various kind of laser sources and things like that. So I have a good grounding, and I'm also a trained certified laser safety officer as well. So one thing we think about, what is the current general impression of handheld processes? If we have a look online, then we can find videos such as this with probably not the best safety considerations taken into place. So this is someone doing some handheld welding. The parts are just being held. You can just see off to the left of the screen someone's fingernails. So they're not wearing any safety gloves or anything like that. If we move on to the second one. Again, we've got someone's hands very close to the process here. Again, not wearing any protective equipment. And these are just some examples, and possibly not the worst examples that I've seen online of people using this kind of equipment. And it's not just welding, so laser cleaning is also a big application. This chap here is doing things correctly. He's got all the right gear on. He's doing things in a safe manner. And then I've got another video here. This is quite a long video, so we're not going to get through all of it. But again, you can see he's wearing the appropriate clothing. He's got eyewear on. He's got a face mask and all of those sorts of things. So there are some good examples, and there's a wide range of terrible examples that we can see online. So first things first, where do we start? So if you have a Class 4 portable or handheld laser, for these kind of applications we're talking about, they are nearly all Class 4. I'm not sure if I've seen any that are Class 3B or 3R. But the first thing we need to do, there is a legal requirement to have an appointed laser safety officer if you're working with Class 4 lasers. So with this, if you bought a laser and you don't have one, you can get an external person to come in and come up with the safety briefings and things like that, or you can send one of your staff for training to become a laser safety officer. The next thing we need to look at is what standards do we need to adhere to. There are a range of standards for lasers, for welding, and general protection against artificial optical radiation. And then once we know the standards, we need to assess the hazards, either from the equipment itself or the process. Following that, you need to assess the working environment. With fixed in situ processes, this can be quite easy because you are in a fixed place, fixed room, and it's easy to do. When we start bringing in the portable element of these kind of lasers, then you really have to see, because you could be working on customer sites. You can't always bring the part to the system. You'll be taking the system to the parts and things like that. And then taking into account all the information we've just kind of reviewed, then we need to look at what safety precautions do we need to take and put into place to make sure we are working safely. So in terms of safety standards, there are a fair few that govern this sort of area. So we have the EU 2006-25. This is a directive regarding the minimum health and safety requirements for employees when they're working with artificial optical radiation. On the left-hand side, we have the personal protective equipment standards. There's two which are laser related. There's a 60825-1, which covers the laser products themselves. The EN 207 is the standard for the PPE and eyewear for laser products. There is a newer standard that's in the works, but it's not been harmonised yet. So this will probably change in the next 2 to 4 years, I would say. And then we have, depending on the application, there's EN 166 for general protective eyewear. 169 covers welding eyewear, and the bottom 3 are for protective clothing, gloves, thermal protection. Then on the right-hand side, we have the large area protection. So this is if we're thinking about the wider area of the working environment, whether it's guards we're using or general health and safety requirements. So 60825-4 is for laser guards. There's also 12254 for screens for laser in working places. So we need to make sure that we are adhering to at least one of these standards. So just a brief one on 169 for welding, because that's probably one of the most applicable. That has prescriptions for protection levels and visual light transmission, as well as shade for welding. The OSTRV and TROS, I think they are more German standards, but they fall within the European standard that I mentioned, and it prescribes protection of not just the eyes, but the skin as well. The laser safety standard EN 207 again goes through protection levels that are required depending on the lasers you're using, along with visual light transmission requirements, marking of the goggles, and defined protection areas. So with some of these in mind, we'll have a quick look at just a brief overview of the kinds of hazards that we're going to be looking at, because it's not just the optical hazards that will arise from these processes. You will often have mechanical hazards depending on the environment you're working with, if there's moving parts, or if you have, I mean, this even extends to automated welding processes where you may have a laser welder on a robotic arm, so you need to watch out for things that might rotate and trap or knock into you. There's always electrical hazards. The processes will quite often involve a lot of heat, either direct or indirect. So we need to look out for that. Some processes may introduce heavy vibrations and things like that. So you need to make sure you're able to work safely. If you're being shaken about too much, then you're not going to be able to keep a steady hand, etc. The two in bold we have there, the laser radiation and the secondary radiation. These are the things that we will mostly focus on in this presentation. And then there are also other hazards posed by substances and materials that can be generated from the process. There's a little bit about that later on as well. And then if you're working in and around gas cylinders or things like that, there could well be risk of fires and explosions. And there may also be other hazards that I haven't covered here. It really depends on the working environment, but we need to kind of take everything into account. So let's move on to the optical hazards. So this slide is just showing a little bit of a comparison between a trivial light source and a laser. So why do we need to wear PPE, or why do we need to watch out for lasers versus whilst we're just walking around with normal light sources and that? So your typical trivial light sources will be emitting a wide spectrum of light. So normally made up of different colours, making your white light. The power levels of these tend to be in the milliwatt to watt ranges, and the radiation is undirected. It basically goes in all directions, and is non-coherent. So if you look at the various kind of arrows there, you can see the light's traveling in all directions. It's not necessarily arriving at the same point at the same time. Now, when we consider a laser, these are typically monochromatic sources. So that will be a single wavelength. Some lasers will have a little bit of a range, so it may be like 1064 plus or minus 5 nanometers. So you have a 10 nanometer kind of band of light, but it's all within the same sort of color, shall we say. In terms of the optical power, here again, we start from the milliwatt range, but we can go much higher in the power range up to megawatts. And even with some of the scientific lasers, they get up to petawatts and things like that. So the difference between the trivial light sources and laser radiation is the radiation is directed. So it is moving in a particular direction. It is also coherent, meaning the photons are temporal in phase. So all of the light is moving in the same fashion and arriving at the same point. Now, to put that into a little bit of context, if we look at a 100-watt light bulb, in this case, we're saying 100 watts of optical power, not electrical power like we would with the old tungsten halogen light bulbs. And then we're going to compare this with a 100-watt laser. So if you take the light bulb, we have 100 watts of optical power that's being emitted in all directions. The worst case scenario for the human eye with the maximum dilation of the pupil is 7 millimeters. So if we take a 7 millimeter cross section from the 100 watts of optical radiation that's being emitted from the light source, we get roughly 300 microwatts entering the eye. With this being focused down to the retina, we get a value of about 610 watts per meter squared. Now, if we compare that with a 100-watt laser, the laser would typically have a small output. We talk of the order of a few millimeters for beam diameter, maybe 2 mil, maybe 5 mil. In this case, all of that radiation is going to enter the eye. So you're getting the full 100 watts, and then this is going to be focused down. And if you run the calculation on the radiant hitting the retina there, we're up at 1.3 times 10 to the 12 watts per meter squared. So if we look at that as a ratio of the irradiation powers on the retina, you can see we are almost 2 billion times brighter with the laser. And this is one of the reasons why it's very important to make sure we have the correct safety eyewear when working with lasers. Now, different wavelengths of light will interact with different parts of the eye. This kind of depicts the various wavelength ranges from the very short UVC out to the IRC wavelengths. So you can see the UV wavelengths, UVC and B typically get absorbed by the cornea and won't travel any further. UVA will go through the cornea, but be absorbed by the lens. Sorry. Visible wavelengths will go to the retina. That's important. That's how we see. The ones we need to watch out for a little bit more are the IRA radiation, because that also gets transmitted to the retina, but we can't physically see them, so we don't necessarily know when we are being hit in the eye with a laser. And then when you move a bit further out to the longer wavelengths for IRB and IRC, then we go back to absorption by the cornea. Now, all of these wavelengths will cause or can cause damage to the parts of the eye where they're absorbed. If we talk about the handheld systems, these are typically somewhere within the 1030 to 1080 nanometer range, whether it's fiber laser or an ND-YAG laser. There are the odd system that's running out at about 1.5 micron as well. So when we're working with these sorts of systems, it's not just the laser wavelengths we need to worry about. Some processes will induce a plasma like welding and the arc, and then we need to look at the plasma and the hazards associated with light coming from these areas as well. So what could we do to protect our eyes when we're working with such lasers or such systems? I mentioned the EN 207 standard earlier. So this prescribes the protection rating required. This is calculated based on the energy and power density of the laser. So this will vary from system to system. We need to look at the visual light transmission, or VLT, of the filter that we are using. For example, if you have a filter that is very dark, it's going to potentially introduce hazards of itself because you can't see what you're doing, you can't see where you're going. So you need to ensure that the workplace is well lit if you need to have a filter like that. Colour view and colour recognition is also quite important. If you need to be seeing what you're doing, different filters are different colours, so they then affect what you can see. I mentioned already the IR, UV and blue light. These are the kind of areas we need to look out for these applications. Comfort and fit of glasses is also quite important. If things are comfortable, people will wear them. If they're really uncomfortable and really hard to work with, then this discourages people to use the right equipment. So there are things like head support systems for heavy glass filters and things like that can be used. If it's in association with a helmet or visor that you're wearing, are they small enough to fit underneath and be worn comfortably? And if you are a glasses wearer and you need prescription glasses, will the frames fit over your glasses, or is there another option to get lenses popped in there as well? Alongside eyewear, there are also face shields and helmets that are available. So we can have flip down helmets and visors like these ones shown over here. Again, good for handheld applications. With these, you can wear prescription glasses underneath or other safety eyewear if you need to. There are full helmets with respiration units on there as well, depending on the process. If you're generating fumes, gases, and that sort of thing, you may need the respiration bits as well. Some come with, some come without. Again, it depends on the application on whether you need them. Now, I mentioned the EN 207 standards and the marking levels. This is just a couple of pictures of a couple of pairs of laser safety glasses we have in the office. So in terms of the protection levels, they are normally denoted with a wavelength range and then the test condition or mode, which is D, IR, or M, depending on whether it's a continuous laser or a pulse laser. Typically for the handheld cleaning and welding kind of lasers, we're looking at either continuous wave for D or the I or R rating, depending on the pulse widths. There's usually also a scale number, or there's always a scale number that needs to be attached to these. These scale numbers basically mean these glasses have been tested and they will last the prescribed amount of time before failing, which for the EN 207 test condition is 5 seconds or 50 pulses for a pulse laser. So enough time for you to realise, oh, something's wrong, I need to remove myself from this situation. Now, recently, or a few years ago, the PPE standards were updated and manufacturers now have to put a date of manufacture on the goggles. So here it's denoted with a little factory symbol, and with these ones, 07 2018. The reason for this is there is now a shelf life and a useful working life associated with the eyewear. There isn't a prescribed standard that says your shelf life must be X and your working life must be X. This is basically, it was left up to the manufacturers to decide what they would like their shelf life and working life to be for their glasses. For our partners, Laser Vision, they have a 6-year shelf life, so you can buy the glasses, you can store them for 6 years, and then the working life they have is 2 years. Doesn't mean after 2 years that you have to throw them away. They can be, after 2 years of use, they can be sent back to be inspected and recertified for a following 2 years, because we know these things aren't the cheapest on the market, and you wouldn't want to have to replace everything every 2 years. Another option for eye protection, if you're going to be working in an enclosure or a cell, one of the most safest things to do is pop a camera in there and have a monitor for viewing the process or viewing the safety of people inside whilst they're working. If that's not an option, there's an option for laser safety windows. There are many different types of filters in various different colours. We can supply these in different sizes and things like that. So depending on the application, there are many kind of windows that you can use to safely view the processes. Once we've looked at the eye protection side of things, we also need to consider the laser safety of the skin. So if we take a quick look at the optical interaction, so this is just a little diagram just showing the different penetration depths of the various wavelengths across through the skin and how transmissive various parts of the skin are. So you can see the UVC and UVB typically stays in the epidermis and the dermis. Down the bottom here we have a list of the kind of effects that happen to the skin. So with the weather being as nice as it has been the past few days, a few people I'm sure will have been sat in the sun soaking up some of the rays, getting a bit of a tan. So that's what we're getting at this sort of level. So that's the arrhythmia, increased pigmentation. When you go to the short UV range, then you have forced aging of skin and things like that. As you move closer to the visible range, you then get more photosensitive reactions. So that's from absorption of the light. And then the further you move out to the IR, that's where we start seeing kind of burning effects. So one of the standards in Germany has a little excerpt about handheld systems. It says, working with handheld laser systems, there remains a residual risk for a reversible injury, i.e. second-degree burns on the finger area or the skin. So basically, when working with an open laser system, flame retardant clothing should be worn. So there are plenty of suppliers out there manufacturing welding protected clothing, which would work also for cleaning applications as well. So we need to make sure our skin is well covered. Now, looking at secondary hazards, you could probably tell from the little icons here where we're going with this. Some processes will be creating fumes, creating particulates and dust and things like that. Now, depending on the size of the particles being generated, this image kind of shows where they're going to get stuck in your airways and where they're potentially going to cause damage. So the larger particles will get stuck in your kind of bronchi. The fine dust will then move further into the lungs. And then the smaller we go, we can get into the alveoli, and the smallest particles can then be transmitted to the bloodstream and work their way around the body and get up to the brain, damaging nerves and things like that. So it's very important that we look at the process and see, are we in an environment, are we creating an environment that is hazardous with the process. So ways around this, we already mentioned the helmet with the respirator attached to it. There are also a range of fume extractors that can be used, which will safely capture and remove dust and particulates. Some will just be pumps. You get ones with particulate filters, again, different filters for different size particles. One important thing to note is always ensure when you're using extraction systems that the air intake is nowhere near the exhaust, because you don't want to be recycling the dirty air back into the environment. A couple of images of a few fume extractors, and some of AILU's other members like TLM, Chemtech and BOFA, other guys you need to contact to get a bit more information on these sorts of things. So looking at the working area, there are a few considerations to be taken into account. The little image here is specific to a welding application, but again, it will be roughly similar to a cleaning application as well. So a couple of caveats with laser safety that you probably get told all the time. Never look directly into a laser, even when you're wearing safety equipment, and never point the laser towards your body or anyone else. One thing you need to ensure is that you are either alone in the working area when you're operating the system, or if there's anyone else present, that they are wearing the correct PPE as well. The other thing to note as well is don't put your hands too close to the laser process as well, even if you're wearing gloves. So another thing to consider for the working area, this is a slide with a lot of information on, ignore some of the numbers on there. This is some information based on a couple of laser welders at 1070 nanometers, the top scenario with 1000 watts output and the bottom one with the 1650 watts output. Now, when people think of lasers, when you watch the movies, you see things on Star Wars and things where they're firing lasers and the blast just kind of keeps traveling and traveling and traveling. In reality, lasers don't stay as a fixed waste. Over distance, they will diverge and become larger. So at some point in the field, there will be a point where the beam is large enough that the power density is no longer dangerous. So if we take the example of the first one, so with a 50 millirad divergence, we need to wait until we're about 100 meters before that's safe to be walking around with no PPE. For scenario 2, again, it's a more powerful laser, but with a smaller divergence angle, the NOHD, or the nominal ocular hazard distance, is 203 meters. So again, it's a little bit more powerful with a smaller divergence, but you need 100 more meters before it's safe. So as you can see with these, for a lot of environments, you're not going to have 100 meters of space where you're working in with no other people in. So with this in mind, we need to make sure we are protecting the area that we're working in. So for large area protection, there are several options. You could use curtains, either fixed in situ on tracks in the ceiling, or on portable frames, as shown over here. There are roll-up curtains available on the market as well, quite handy for chucking in the boot of the car and taking with you to site. There are different options for laser safety barriers, again, whether they're fixed in situ or portable on casters and things like that. Relevant certification for the laser safety standards will be the EN 60825 or the 12254 for these. And then moving on to the technical and organizational protection. So we already mentioned, if you have a class 4 laser, that you need to have a laser safety officer appointed. Other things for the area that should be considered are warning signs. If you are in a prescribed room that's a laser room, then there should be an emission sign, which can then be connected to the laser, so it lights up when the laser is in use, warning people not to enter. Alongside that, an interlock system. Here, if someone was to open the door, then this will shut the laser down, making it safe. There are optional things like PPE storage. We have just over here, we have a little box on the wall. Again, but not a necessity, but maybe worth having, just to make sure the right equipment is in the right areas. But there you are relying on people putting things back where they should. If it's a lone working situation, a viewing window would be a good idea, just to make sure people can check on you, make sure you haven't collapsed or had an accident yourself, and things like that. And if you're working, especially on external sites, on customer sites, then employer's liability insurance as well. Now, moving on from those, how can we help you? There are a bunch of different filters. If you have a look at, the picture that I showed earlier with all the glasses on, there's so many different filters covering different wavelength ranges. Here we have a couple of examples which we typically recommend for things like welding and cleaning. So there's the T1KO3 filter, the P1P16, filter. The T1K03 is a glass filter. It's almost clear, maybe slightly grey, so you have a good colour view. It will protect for the IR against the laser wavelengths. The P1P16 is a plastic filter, so it will be a little bit lighter, but this also provides some blue light protection up to 474 nanometers as well. There are various accessories with these kind of frames. They sit very close to the face. If you need to wear prescription glasses, you wouldn't be able to wear these on top of those. However, there is an RX insert like this available where you can get your prescription lenses fitted, and these simply click into the frame. You have options for standard temples. If it's a heavy glass filter, then there are head straps and head support systems as well. If you're going to be wearing them for a long time and it's heavy, then a head support system is recommended. These are the kind of protection ratings these glasses will provide. We have some plastic filters as well. These can be worn over glasses as well. So we have a number of filters, but these are two popular ones as they provide the UV blue light protection and cover the IR. They give good color recognition for applications with the low plasma. The P1P18 is a good filter because it has quite a high visual light transmission of about 52%. The P1L07 is a lot darker, but much more suitable for applications with a high plasma. This frame style is quite good because we have replaceable temples. If you were to drop the glasses or break them, it's a quick, easy replacement. So from our partners Laser Vision, we do have a new full face visor, the FS1. So this is the entire body is certified to EN207 and the laser safety filter itself. Depending on which filter you choose, we have a shade 3 and a shade 1.7 on this as well. Mechanical strength as well, according to the EN166. And this will cover your entire face, so covering protection of the eyes and skin. For laser safety windows, again, there is a wide range of materials. This is just a small selection of the materials. There's a 3mm thick and 6mm thick options with, again, so similar to the previous ones. We've got low plasma, the high VLT gold filter is quite good. For higher plasmas, we have the blue filter, and then we have the P1H09, which is a dark green, and good for stronger plasmas. So these are available typically in dimensions up to 3 by 2 meters, and various standard sizes in between. Custom sizes also available. On the large area protection side of things, we have the curtains. One good option is the E25 barrier system. So this is a modular system. Starts off with 2 panels. Comes in a nice, easy to transport package, and it folds down to a single panel. So you have the option of adding up to I think 7 panels, so you can have 9 panels in total. With their special light tight hinge, you can place each panel at any angle from another. So if you're working in a confined space, you've got the option to just fit it around where you are. And then again, for storage, it folds down quite nicely. Lockable casters, so they can be fixed in situ and wheeled away. And there's also the option of adding a laser safety window to these as well, however large you need them. Again, these will be specified dependent upon the laser that you're using. Okay, and the other thing we offer is laser safety training services, typically a 2-day course. Currently, we're mostly running these via MS Teams. online because it's easy for people to attend. We have a standard kind of syllabus that we cover. We can also do bespoke training courses. We can do on-site courses. We can do exclusive courses just for your company, your employees, or like I say, the general laser trainings anyone can join. So we have our next scheduled course for the 1st and 2nd of October. First day covers the laser safety awareness, and then the second day covers the LSO part. If you just want to do the laser safety awareness, then you can just do day one. If you want to do the laser safety, obviously you need to do both days. But the laser safety awareness is great for anyone that's working with lasers or in or around the area where there may be lasers. It's a QR code here. You can scan that. It will take you to our website where you can register. And just a few of our supplier partners as well. And here's my contact details. So if you have any questions about laser safety, about your lasers, about what you need to do, feel free to give me a call on the office or drop me an email. I'll be more than happy to help. So with that in mind, I will thank you all for your attention. And I guess we can move on to the Q&A.
Yep. Okay. Thanks very much, Preetesh, for that. We do have some questions lined up for you. So I will take as many of those as we have time for. The first question was about the particle size. This question came in before the slide where you showed the particle sizes in Fume.
Yeah.
So I'm assuming that it relates to that. They're asking what particle size is typically generated by these types of lasers. Well, as I saw from your slide,
yeah,
you're talking microns for particles and nanometers for dust. Fume.
Back this one.
Smoke, steams and gases.
Yeah. So 100 microns for kind of raw dust, and then down to nanometers for steams and gases. So
okay. Then we did have several questions on the same topic about a laser welding helmet with RPE protection, in other words, the respiratory PPE. So I guess it's probably worth addressing that for welding and for cleaning, how you would address those, and is there a product that exists
as in for helmets?
For a helmet that's combined with the
respirator.
Yeah.
I mean there are some helmets out there with the respiratory parts to it. We don't work with anyone on that front. As far as I'm aware at the moment, I don't think there's any with built-in kind of visors or laser safe filters. So at the moment, you would most likely have to wear a pair of laser safety goggles underneath the helmet. So here you'd have to go for a small frame that fits comfortably underneath them. I know that our partners are working on a helmet, but I'm pretty sure that's not one with a respiratory thing on it as yet. I guess with the increase in these kind of applications, it's something we probably will see soon, but I don't know of anything off.
My understanding is that there are some people working on it right now, but the products aren't yet launched. So I imagine that at some point, when you see videos of people doing laser cleaning responsibly, they're wearing one of those respiratory helmets and a pair of laser goggles underneath. One of the questions specifically asked about that. I weld various materials with laser, and I'm going to be getting a handheld laser. What's available with a laser rated helmet with RPE, as I can't find any that are all in one on the market. I can find arc welding RPE helmet and then use laser glasses, but that would be cumbersome.
Yeah. So currently that's the best solution. It's not ideal, but it's what we have to work with at the moment.
I guess for welding, it's fairly common for people to have a localized fume extractor nozzle, situated.
Yeah, you can have like an under table or over table extractor.
But I think for laser cleaning in particular, the hazards are that much higher.
Yeah, you're going to be creating smaller particles.
If I was doing that all day, every day, I would want to have the respiratory helmet.
Yeah, I'd agree.
So probably watch this space is the honest answer there. Okay, that's the first 4 questions. A couple of people have asked about the barriers, the portable barriers. So on the barrier, can light escape below the barrier when where the wheels are? And if so, how do we cover this area?
So that you could cover with extra barrier material just to cover the gap. For most processes, because you're going to be quite high up, you're relatively safe. But you need to do a risk assessment basically based on the environment. It's kind of difficult to say. If you're obviously if you're laser cleaning something that's going down to the ground, then you're going to need to block that off.
Yeah.
Okay. It'll be different for each application.
There's another question about can it only be a barrier without a ceiling around the handheld laser welder? So that's looking at the other end, I suppose, the top rather than the bottom.
Yes, I mean it can be. Again, you need to look at the overall environment and make a judgment as to whether there's going to be any reflected radiation exiting at high angles, or if you have like a mezzanine floor or a floor above you where people can see down, in which case you would need to cover the top as well.
Okay. Now here's one from David Samuel. I've heard mixed reports that if a class 4 laser is housed in a suitable interlocked enclosure, such as a laser mounted to a robot in an enclosure, then the system can be classified as class 1 and therefore an LSO is no longer needed. Could you clarify?
So if the system itself is classified as a class 1 and can't be operated, if it's interlocked suitably and can't be operated with the doors open, then you wouldn't need an LSO, as far as I'm aware, because if it's been tested and certified, checked for radiation leaks.
I think if, for example, if it's a robot inside an enclosure, I can imagine that there are times when you would have to work inside the enclosure to, test the beam or do things, in which case it is a class 4
then it's
laser.
a class 4, yeah.
So I would think that if you have a class 4 laser, that is something you need to work inside and for maintenance or
yes, if you're needing to open it up, then yes, it would be prudent to have a LSO. I'll double check. I'll need to double check that as well. But yeah, I think if you're having to get access to the area, then it's fine. If it's a fully automated process, say there's a conveyor coming through with parts on, and that whole system is enclosed and you can't get anywhere near the laser as a class 1, then you'd be okay. But if you're having to go in, then I think you need one.
Here's a question: how much of a specular reflection of stainless steel should be considered when evaluating the safety of handheld laser welding?
That's a good question. I couldn't give you a number off the top of my head.
I mean, I guess with stainless steel, it could be like a mirror finish, so you have to assume that the more or less the full power of the laser could be.
Yeah, I mean, when it comes to laser safety, we always work on the assumption of the worst case scenario. So a direct reflection, so 100% of the power would be probably what would be used for the calculations.
Okay. There's a handful more questions to go, but we've got plenty of time, so hopefully we'll get through them. So are there any templates for risk assessments available for handheld laser equipment? I've not seen any per se, but I would imagine that there should be some knocking around. I can ask our partners to see if they've got one, and if we can, I can distribute that with the presentation after. Ask Google or ask ChatGPT.
Oh yeah, that also works as well.
But yeah, I think at the end of the day, laser risk assessment is your responsibility if it's your system. So
yeah, well, either your responsibility or your laser safety officer's responsibility. So
yeah. Okay. So there's a couple of questions about skin protection for arc welding. So leather gloves, e.g. Skin protection used for arc welding, traditional conventional arc welding, is that adequate for laser welding? And somebody else has asked that I've seen a few suppliers claim that they have laser related clothing and glove, but we're not aware of standards to certify this PPE. Do standards exist, and should it be recommended to use laser resistant PPE in addition to heat resistant?
I think heat resistant should be fine. I would need to check if there were protection ratings for, laser protection ratings for clothing. I know our partners used to offer some laser safe gloves and things like that as well, but I'm not sure what they were certified to because that was before I started working with them. But that's something I can check and come back.
I don't think there is a specific standard for laser resistant PP. Is there?
No, not that I can think of off the top of my head.
So is there any particular differences of fume extractor for arc welding versus laser welding?
Oh, that I would probably have to refer that to someone who knows more about the fume extractors.
I mean, what I would say is that, you know, the companies that you mentioned, BOFA and TLM, and there was a third.
There's Kentech as well.
Kentech, who provide those systems would certainly be able to tell you what's needed. But I would imagine that they're fairly similar because at the end of the day, it's generating the same sort of fume.
Yeah.
But it could be slightly worse with laser welding because it could be slightly smaller particles. Okay. Okay, somebody's saying we sell the IPG handheld laser welding and cleaning systems. When discussing modular systems, we were told that there's not allowed to be any gaps, including between the ground and the bottom of the panel. So that's sort of coming back to the
enclosure
idea. So I think probably it's fair to say that a fixed, you know, room type enclosure
is the best.
The best option.
That's always the best option. But I mean, I know with some of the laser cleaning applications and things like that, you are cleaning large things that are fixed in place. So you can't always bring the part to where you want to do the cleaning. You need to take the laser. There. So you'd have to find a way to block off the gaps.
Okay. Somebody's asked a question for the safety side of handheld laser, what this webinar should be about. Why is the checklist S219 from GBETEM not mentioned? PP is nice, but first make equipment safe.
So the laser equipment is governed by the 60825 for general safety. That I'm aware of. The standard that was mentioned there, I'm not.
So I guess what they're saying here is that obviously that if you buy a handheld laser, you want to be sure that it's compliant and it's safe.
Yeah.
In other words, it matches the EU standard. So I'm not familiar with that S219 checklist. But again, I think what we'll say is if we after the webinar, when we answer the question, we'll review the questions that have been asked. And if we can find any more supporting information, those answers will go to everyone. Okay.
So there was one thing that I forgot to mention actually, just when we were talking about the eye protection and the marking. So a lot of these systems come from outside of the UK or outside of Europe. And what you'll find sometimes with some bits of kit will come with safety glasses. They may well not be certified to the EN 207 standard. So rather than having this sort of information on there, you may just have the OD level. If you're working in Europe, then they are not permissible for use. If there was an accident or anything whilst wearing those kind of glasses, then the company or the LSO would have to bear full responsibility for those sorts of things. So it's always worth checking that you have the correct markings on the glasses as well.
Okay. So there's 3 more questions and then there's a raised hand which we can address as well. So regarding protection coat, what was the recommendation again? I'm concerned about the back reflection of 2 kilowatt single mode handheld laser. Is there any burn risk on the skin?
Can you repeat that one again, sorry?
Regarding protection coat, I presume they mean like overalls.
Overall,
what was recommended again? I'm concerned about the back reflection of 2 kilowatt single mode handheld laser. Is there any burn risk on the skin?
So for Skin, yeah, so any flame retardant clothing or any welding resistant clothing should be fine for that sort of application.
Okay. You see videos on the internet of laser cleaning. The wide beam is cleaning the material without the gun touching the material. Is there any regulations for the UK on this, as it seems dangerous?
So when I mentioned the standards, we had a few which related to welding, but as far as I'm aware, there isn't one for cleaning as yet.
I'm not aware of one.
Yeah.
No.
So yeah, I mean, it depends on the focal length of the lens that you have on the cleaner or the cleaning head that you're working with. But yeah, as far as I'm aware, there's no standard as yet.
I guess laser cleaning is potentially a lot more dangerous than laser welding, because obviously with laser welding you can put interlocks that mean that you have to be in contact with the workpiece.
Yeah, you have the clamps.
But with laser cleaning you can literally point the gun
and shoot anywhere. Yeah.
So it is more dangerous, but you know, that's why we're having this.
It's one of the reasons we put this on. Yeah, it's one of those, you like to think that people will work responsibly with things like this, but there is always that risk.
Okay. And then somebody's asked, please do you use beam shaping? So I don't know whether beam shaping is used in laser welding or cleaning specifically.
There might not be, I mean, there will be some focusing optics which will be shaping the beam to generate that line for the laser cleaners. For the laser welders, again, you have an optic which then focuses the laser down. So there will be some.
Specifically for beam shaping, I mean, a lot of high power laser welding is done with beam shaping. I think from a laser safety point of view, it's the same issue.
You're still facing the same requirements. Yeah.
Okay. So there are no open questions. There was a hand raise which has gone down. I don't know if David Samuel wants to make a point or raise a question, or whether that question's been answered. So unless there are any more questions, okay, one's just popped up. So if someone says, if using a face shield, are additional laser glasses still required?
So again, it depends on the laser specifications. We would always need to run run the calculations to find out which LBE ratings are required. So the ones that I showed earlier, they have quite high protection levels, but if they're not high enough, then you may well need to wear a pair of glasses underneath.
Yeah. So the point of the face shield is, I guess, that it does have laser filter.
It's got laser filter. The one from Laser Vision is also, it's been designed for welding. So the two, I think we have three different filters we can offer. One's being withdrawn. So there'll be two with two different welding shades as well. So
yeah.
So there's a shade 1.7 and a shade 3. But yeah, if you need higher laser protection, then you could get a laser safety filter that covers the protection level, and then use a traditional welding shield on top.
Okay. So that's the end of the list of the questions. If anybody else has a question, then we have about 5 minutes left until we will close the webinar. If there are no more questions, then we'll probably just say thank you very much and close the meeting.